Hello viewers, welcome back to our YouTube channel 3D Parametric Solid Model Drawings. Today we will create an assembly file of suspension in Siemens NX. Okay, in this video you will learn the full assembly modeling of this model. You can see here, this is my part list of the suspension model. Each part will be established one by one in this assembly by using the various type of assembly mates. Okay, that's it. So let's start the tutorial. Now we will activate the new button from here. It will keep as an inch assembly file. Okay, alright. Enter the file name suspension on here. Okay. Now we will set the location of the part file like this and save the file in the suspension folder. At first, now see add component command has already been activated on here. And click OK. So now we will select the front side plate right part. Okay. Now you can see my part preview is visible over the right side. It looks great. Under the placement area, we will select the absolute origin option on here, which means that my part is fixed on the assembly origin point. Okay, now we will select the entire part option under the reference set area, which means that all the datum planes and 2D sketches of this part are visible here in this assembly, otherwise not visible in the assembly. Now see here, my first part has been placed in this assembly. Go to the Part Navigator dialog box and choose the Assembly Navigator option. Now we will go on the View tab and activate the Show and Hide button and hide the visibility of all the datum planes and 2D sketches of this part by selecting this option. Okay, now my part is looking clearly in the assembly design window. Okay. Now we will activate the Show Degree of Freedom command from the Component Position panel. And select this part. Now you can see here these red arrows in the design window. It is denoting here that the 3 rotational and 3 transitional degrees of the freedom on this part. Okay, alright. And now we will activate the assembly constraints command. Choose the fixed constraint from the constraint list and apply the fixed constraint on this part. Okay, that's it. Now my part is fully defined in this assembly, and save the assembly. Activate the add component command from here and insert the front side plate left part in this assembly. But this time we will select the move option on here before placing the part in the assembly. Okay, alright, now we will check the degree freedom of this part like this. Now we will activate the assembly constraints command. Under the orientation list, we will select the align constraint option. Now it is asking you to select the two components on here. So we will select the front face of these two components. And click the apply button. Okay, now see the result. The align constraint is applied on these two components. Now we will select the z-axis on the 3D coordinator, okay, and set the angle 90 degrees to rotate the assembly in opposite direction. Mostly 3D softwares like SolidWorks or Autodesk Inventor, I use the view cube to rotate the model, but this software has not provided such a good system. So if we want to rotate the model, then we have to do it with this system. Okay, alright. So now we will select this one and apply another align constraint on over it. Okay, that's it. Now we will select the infer center oblique axis constraint from here and apply the constraint between these two whole center axes of the part like this. Click OK to finish the command. Now we will activate the move component command from here and drag the front side plate left part in the inside direction. Now we are going to insert the next part. Place the front upper arm mount part in this assembly. Okay, now drag the part like this and rotate the model in this position. Hide the visibility of the sketch and datum plane like this. Now we will fix the touch constraint between the front face of this part and back face of the front side plate right part. Okay, that's it. In the same manner, give another one mate on here. Okay, alright. Now drag the model like this. Now we will fix the touch constraint between the side face of front side plate right part and inner face of the upper arm mount part. Okay, alright. In the same manner, give another one mate. Okay, alright. Now we will apply the distance made between the top face of the front side plate right part and back face of the upper arm mount part. Set the distance value 0.09375 inches. Click OK to finish the command. So now my assembly is fully defined. Now we are going to insert the next part, front shock brace. Okay. Now we will go to the edit front side plate right part. Okay, and change the color of this part as light green. Okay, now my model is looking perfect. In the same manner, we will change the color of the two remaining components. Okay, now see, my assembly is looking perfect. Rotate the model in this position. Now we will fix the infer center oblique axis constraint between the whole axis of shock brace and front side plate right part. Now drag the part and fix another axis constraint over the opposite side hole like this. Now we will apply the touch made constraint between these two faces of the components to fix it. Okay, that's it. So now we will create a new inch assembly with the name front upper arm underscore 1. Okay. And insert the front upper arm part in this assembly. Hide the visibility of the datum plane and sketch of this part. Okay, now we will fix the part by using assembly constraints which we had done earlier on my previous assembly. Okay, that's it. Now we will insert the pillow ball part on here. activate the move component command and drag the model like this. Fix the center axis constraint between this cylindrical face and the whole of the front upper arm part. Okay, alright. And now we will fix the distance constraint between the top faces of the front upper arm and pillow bar part. And fix the distance value 0.0491 inches. Now we will hide the visibility of the constraint from here. Okay. Now we will change the color of the front upper arm part from here as light gray. Okay, it looks great. And change the color of the pillow bar part as light gray. Okay, now see, my assembly has been completed on here, so we will create a new assembly. Name it as front lower arm underscore 1. Okay, alright. And insert the front lower arm part in this assembly. This assembly will be made the same process as it is that we created just before. Okay, now my assembly has been completed on here. So we will close the two assemblies on here and back to my suspension assembly. At first, we will insert the front upper arm underscore 1 subassembly in this assembly. Okay, that's it. Now rotate this assembly in this position. Now we will activate the assembly constraints command from here. Choose the touch align constraint option from the constraint list. Okay, and apply the center axis constraint between these two whole axes of the component. Okay, that's it. Now select this face and rotate the model. Select this face, okay, and fix the touch constraint between them. Okay, now see. Now we will place the front lower arm underscore 1 assembly on here. Now rotate the assembly in this position. Same constraints will be applied in the following way that we had done earlier. Okay, now my front lower arm underscore 1 assembly has been properly fixed on here. Drag this assembly by activating the move component command. Now see the result. Now we will place another copy of the front arm assembly on here. Okay, and drag the assembly like this. We will fix the center axis constraint between the whole of the front upper arm assembly and the whole of upper arm mount. Okay. and apply the touch constraint between the internal face of the front upper arm assembly and the rear side of the front upper arm mount. Now rotate the assembly minus 90 degrees on here. Okay, we will place the second copy of front lower arm assembly on here. And drag and rotate the assembly like this. Now we will apply the same constraints in this assembly that we had done earlier on the front upper arm assembly. Okay, that's it. Now all the components are fully defined on here, so we will insert the next part in this assembly. Now we will place the front lower arm brace part on here. Okay, alright, and rotate the component in this position. Now drag the part by selecting its Z-axis. Okay. And fix the center axis constraint between these two holes of the components on here. In the same way, we will give another center axis constraint between the opposite side holes of the components like this. And now we will place the two copies of front lower hinge pin in this assembly. Now activate the assembly constraints command and fix the center axis constraint between the axis of pin and hole of front lower arm assembly. Okay, now we will fix another axis mate over the opposite side. Now see. Select the touch constraint from here and select the face of front lower arm and select the face of the front lower arm brace to apply the touch constraint on over it. Now we will select the front face of the lower arm brace part. Okay, now choose the align constraint option on here and select this slot face of the pin and apply the align constraint on over it. Okay, apply another align constraint over the opposite side pin like this. So now we will insert the front upper hinge pin in this assembly. Okay, rotate the pin in this position. Now place another copy of this pin. Okay. Activate the assembly constraints command. Now choose the infer center oblique axis option on here and fix the center axis constraint between the axis of pin and hole of the front upper arm assembly. Now choose the align option on here, okay, and select this face and slot face of the pin and apply the axis constraint over it. Okay, now we will fix another pin over the opposite side in the following way. Okay, that's it. Save the assembly. Now we will insert the E-clip part on here. In the Add Component dialog box, we will go on the Duplicates section. Fix the count value 8 on here so that 8 copies of this part at a time. Okay, alright. Now you can see here in the assembly navigator, 8 copies of this part has been placed. Okay, now we will drag each eclipse one by one on here. Now see the result. Now we will prefer center axis mate on here. Select the outer cylindrical face of the E-clip. And select the front lower hinge pin. Okay, now see. In the same manner, we will fix the 3 more E-clips over my suspension assembly in the following way. Okay, now see the result. Now rotate the assembly on the rear side. In the same manner, we will fix the remaining E-clips on the back face of the suspension assembly like this. Okay, now my center axis constraints have been fixed between all E-clips and suspension assembly. Now we will activate the move component command and drag the E-clip in the reverse direction. In the same way, we will move the 3 more E-clips on here. Okay, now activate the assembly constraints command. Now choose the touch constraint option on here and fix the constraint between the front face of the lower arm brace part and back face of the E-clip. Okay. Now we will fix the another E-clip on here. Select this one and this one. Okay. Now we will some more E-clips on the front upper arm assembly in the following way. Now rotate the assembly on the rear side and fix the remaining E-clips like this. Okay, now my all E-clips are properly placed over the suspension assembly. So we will insert the next part on here. Place the part front suspension adjustment clip in this assembly. Now we will insert the two copies of this part. Okay, now rotate the model in this position. Okay, now we will fix the adjustment clip over the E-clip in the following way. Okay, now my front suspension adjustment clips are properly placed on here in the suspension assembly. So we will insert the next part on here. Place the two copies of the shock bushing part in this assembly. Okay, now we will apply the center axis constraint between the hole of front shock brace and hole of shock bushing part like this. Okay, that's it. Now choose the touch constraint option on here and select the front face of shock brace part, okay, and select the back face of shock bushing part and fix the touch mate on here. In the same manner, we will apply another touch constraint between the second shock bushing and shock brace part. Okay. And save the assembly. So now we are going to create a new assembly on here, which name is ball end underscore 1. Okay, alright. And place the part ball end in this assembly. Now we have selected absolute origin option on here, okay. So first we will activate the assembly constraints command and we will choose the fixed constraint on here. Apply this constraint over the ball end part like this, okay. We will insert the 0.25 ball end part on here. It will keep as a move position. Now we will change the color of this part on here as light gray. Okay, now my part is looking perfect. We will open the visibility of datum coordinate system of this part. Okay, return to the assembly environment. And drag the part by activating the move component command. Now we will fix the center axis constraint between these two holes of the components. Okay. Choose the align constraint option. Select the exit plane of the bar end part and select the exit plane of 0.25 ball part to fix the align constraint. Okay, now see the result. My 0.25 ball part has been properly placed on the center of the ball end assembly. Okay, now assembly has been completed on here. So now we are going on to create another new assembly on here. Which name is shock strut. Okay, alright. And place the part shock shaft in this assembly. and apply the fixed constraint on this part. Now we will insert the piston part on here. Okay, alright, we will activate the assembly constraints command and we will choose the center axis constraint on here. Apply this constraint over the outer cylindrical face of the piston and outer cylindrical face of the shock shaft part. Now drag the piston on the back side. Okay. And insert the E-clip part in this assembly. Now we will place the two copies of this part. Okay, drag the E-clip from here. And fix the center axis made between the outer cylindrical face of the E-clip and outer cylindrical face of the shock shaft part. Now we will apply the touch constraint between the top face of the E-clip and the back face of the piston. In the same manner, we will fix the second E-clip over the opposite side of the piston like this. Now we will hide the visibility of the constraints by activating the show/hide command. Okay, my shock strut assembly is looking perfect. Now rotate the assembly minus 90 degrees on here. Activate the move component command from here and select the piston part, okay, and drag the part in the back side. Now we will fix the align constraint between the top face of the piston and slot face of the shock shaft part. Okay, that's it. Now we will rotate the assembly. And place the ball end underscore 1 subassembly in this assembly. Now we will apply the touch constraint between the front face of the ball end subassembly and this slot face of the shock shaft part. Now we will select the inner oblique center axis constraint on here and fix this constraint between the two axes of these two components like this. Now we will place the spring cup part on here. Okay. Activate the assembly constraints command. Choose touch option. Okay. Select this whole face. Okay. And select this face and apply the touch constraint between them. Now we'll select this cylindrical face of the shock shaft part and this cylindrical face of the spring cup part and apply another touch constraint between them. Okay, now see the result. Now we will activate the move components command and rotate the spring cup part like this and hide the visibility of the constraint from here. Okay, now we will create another new assembly from here. Its assembly name will keep shock cortege underscore 1. Okay, that's it. Now activate the add components command from here and place the part shock cartridge in this assembly. Okay, now choose absolute origin option and select the entire part option and click OK. Now see, now choose an isometric view and hide the visibility of datum plane and sketch of this part like this. And now activate the assembly constraints command and apply the fixed constraint over this part. Save the assembly. Now choose add component command and place the part O-ring in this assembly. Okay, choose move option. Okay, now drag the O-ring from here. Okay, and rotate the part in this position. Okay, alright. Now we will edit the O-ring part and open the visibility of datum coordinate system of this part. Okay, return back to the assembly. And activate the assembly constraints command. Select the touch align constraint from here. Choose center axis option, select this hole. Okay, and select the Z axis of the O-ring and apply the mate constraint. Okay, now see. Now we will open the O-ring part separately from here. Okay, now go to the part navigator button from here and open the visibility of datum coordinate system from here. Okay, alright, now we will create a datum plane at an offset distance value 0.063 by 2 inches away from XY plane. Okay, that's it. Now see, my plane is created on this part. And now we'll activate the mirror feature command from here and select this plane. Okay, choose mirror plane option, select the XY plane. Okay, now see, my two planes are created here over this part. Now we will resize the datum plane from these points. Now see. In the same manner, we will resize the bottom plane on here. Okay, that's it. Now see. Save the file and close it. Now we will return back to the shock cartridge assembly. Okay, and open the visibility of O-ring part. Now we will activate the assembly constraints command, select the touch option. Okay, now we will select this plane of the O-ring and select the internal face of the shock cartridge part and apply the touch constraint on here. Okay, save the assembly. Now we'll place another part on here in this assembly. Choose the shock cartridge spacer part. Okay, alright, drag the part like this, rotate the part in this position and fix the center axis made between these two parts like this. Okay, that's it. Now we'll choose the touch constraint option from here. Okay, now we'll go on the rendering style drop down menu from on here. Okay, and select the static wireframe option on here. Now select this plane of the O-ring. Okay, alright, and now choose shaded with edges option from here and select this face of the shock cartridge spacer and apply the constraint on here. Okay, alright. Now we will activate the section view by selecting this plane Now see, shock cartridge spacer has been properly fixed over the shock cartridge part. Okay, now deactivate the section view from here. Now we will hide the visibility of coordinate system and atom planes from here. Okay, that's it. My assembly is looking perfect. Now we'll add another part on here. So now we will select the shock cartridge cover part and select the O-ring part. Okay, and place the part in this assembly. Now we'll drag the part like this. Okay, now see. Now we will drag the part in this position. Okay. Now we will rotate the O-ring in a straight position. Okay, alright. Fix the center axis constraint between this hole of the shock cartridge part and Z-axis of the O-ring. Okay, that's it. Now select this plane and this internal face and fix the touch constraint on here. Select this one and this one, okay, and fix another touch constraint between them. Okay, alright. Now we will apply the touch constraint between these two faces of the components like this. Okay, now my shock cartridge subassembly is looking perfect and it has also been completed on here. So now we are going on to create another subassembly on here, which name is shock body. Okay, alright, and place the part shock body 1.3 length in this assembly. Now we have selected absolute origin option on here and now we will choose the entire part option. Okay, now see on here and give the fixed constraint over this part. We will insert the shock cartridge _1 subassembly in this assembly. Okay, its position will keep as a move on here. Now we will drag and rotate this component like this. Hide the visibility sketch and atom planes on this assembly to clear the view. Okay. Now we will fix the center axis constraint between these two assemblies like this. Okay. Now we will drag the shock cartridge assembly on here. Select this one, okay, and select this and apply the touch constraint between them. Okay, alright. Okay, now we will select the angle constraint from the list and now you can see here my 3D angle option is already been activated in the subtype section. Okay, so let's select this face of the shock body 1.3 length part and select this face of the subassembly of shock cartridge cover. Okay, now see my 180 degrees angle is fixed on here and click OK to apply the angle constraint. Okay, that's it. Now we will hide the visibility of the assembly constraints on here. Okay, alright. Now we will create another new subassembly on here. Now this assembly name as shock absorber and click OK. Alright. Now we will place the part shock spring adjustment nut on here. Okay. Now we will select the absolute origin option. Okay. so that this part is placed over the origin point of the assembly. Okay, alright. Now we will activate the constraint tool and apply the fixed constraint on over this part. Okay, alright. Now we will activate the add components command from here and place the part suspension spring on this assembly. Now select move option on here and click OK. Now we will drag the spring like this. Okay, activate the constraints command from here, choose touch align option. Okay, and select the infer center axis option. Okay, at first we will select the axis of the spring and then next we will select the whole of this part. Okay, and apply the axis made between them. Now see, now drag the spring in this direction. Okay, by selecting its z axis. Okay, now we will place the subassembly shock body on here. Okay, that's it. Now drag this subassembly like this. Okay, and rotate the assembly in this position. Okay, alright. Now we will apply the axis made between these two components like this. Okay, that's it. Now drag the assembly in this direction. Okay. Choose zoom all, click save. Hide the visibility of the sketch and data planes like this. Okay. Now we will choose on here distance constraint. Okay, and select this face. Okay, select this face. Okay, and apply the distance made between them. Fix the distance value 0.4003 inches. Okay, alright. It looks great. Now we will apply the angle mate. Okay, select this face and select this face and click OK. Okay, now you can see here my 180-degree angle constraint has been applied over this part. Okay, alright. Okay, now we will place the subassembly shock strut in this assembly. Okay, that's it. Now see. Now we will rotate the assembly in this position. And drag the assembly like this. Now we will select the touch align constraint from here. Okay, and select the touch constraint. Okay, now select this face of the spring. Okay, rotate the assembly and select this internal face of the shock strut assembly and apply the touch constraint between them. Okay, now see, it looks great. Now rotate the assembly minus 180 degrees from here. Okay, and now we will activate the assembly constraints command. Select the angle constraint. Okay, now we will select this face of the assembly and select this face. Okay, and apply 180 degrees angle constraint on over it. Alright. Now we will activate the edit section view from the design window. Okay, now see. Now choose set plane X plane. Okay, now see. Now we'll activate the move component command from here and select the shock strut assembly and drag this assembly in this position. Okay, alright. Now we will create 3 subassembly arrangements in my shock absorber assembly. Number 1 is open, number 2 is closed, and third is middle. Okay, so first now we will give 3 touch constraints on this assembly. Now we will activate the assembly constraint tool. Okay, and now see here my preferred touch constraint already has been set on here. So now we will select this face of the E-clip. Then next, rotate the assembly and select this face of the shock voltage cover part. Okay, alright. Now we'll rotate the assembly in this position. In the constraints folder, drag the browse bar from here. Okay. Now select this touch constraint. Okay, and its name open. Okay, alright. Now right click and choose suppress option. Okay. Now we will activate the assembly constraints command from here. Now we will choose this internal face. Okay, rotate the model and select this face. Alright, and apply another touch constraint between these two components. Alright. Now we will change the name of this constraint. It will keep closed. Okay, that's it. Now we will suppress this constraint. Okay. Now we will drag this subassembly in front side. Okay. Now select this face. Okay. Rotate the assembly and select this face of the spring and apply another touch constraint on here. Now rotate the assembly minus 180 degrees from here. Okay. Now we will change the name of this constraint. It will keep middle. Okay, now you can see here my 3 assembly constraints has been created on here and all the constraints are suppressed. Okay, that's it. Okay, alright, save the assembly. Now we will activate the arrangements button from here to define the alternate position of the components. Okay, in the assembly arrangements dialog box, we will activate the new arrangements button. Okay, and its name is open. Okay, alright. Click copy button. Its name is closed. Okay, and the third is the middle. That's it. Now close the dialog box. Now we will go on the shock absorber assembly, then arrangements, and choose the arrangement open. Okay, now we have selected open constraint. Right click and choose the arrangement specific option. Then we will place the check mark on this constraint to enable it. It means that when we selected the arrangement open, then this constraint becomes active. Okay, that's it. In the same manner, we will select the close option under the arrangements area. Okay. Then go on the closed constraint, right click and choose the arrangement specific option and place the check mark on this constraint to enable it. Okay. Now select the middle option. Okay, and select the middle constraint, right click, choose arrangement specific option and place the check mark over this constraint. Now my 3 assemble arrangements are ready for this assembly. So we will test the arrangements. So now we will select the arrangement 1 default on here. Okay, save the file. Now we will check the assembly arrangements one by one on here. Now go to the arrangement section. At first we will select the open. Now see the result. Okay, then next we will select the closed. Okay, now see the result. Now choose the middle option, see. And finally go to the default assembly arrangements. So now you can see here how easily the position of these 3 touch constraints can be changed from a single assembly by using this method. Okay, that's it. It looks great. Now my shock absorber assembly has been finished on here, so we will close this assembly. And back to my suspension assembly. Now we will place the shock absorber assembly in this assembly. Okay, and rotate the assembly in this position. Now we will activate the assembly constraints command and choose the infer center axis constraint. Okay, select the whole axis of this shock absorber assembly and select the cylindrical surface of shock bushing part and apply the axis mate between them. Now select this one and select the back face of the shock absorber assembly and fix the touch mate between them. Okay, that's it. Choose the front view. Okay, and drag the assembly like this. Select the shock absorber assembly and go to the arrangements section and select the middle option. Now see the result. Now we will place another copy of this assembly on here. In the same way, we will fix the second shock absorber assembly over the opposite side of the suspension assembly that we had done just before. In the same manner, we will change the arrangement of this assembly as middle. Okay. Now we will activate the move component command and rotate the front lower arm part in the following position. Okay. And drag the shock absorber assembly near the side of the front lower arm part like this. Okay, alright. Save the assembly. Okay, now we will create a new assembly. Its name front hub carrier left underscore 1. Click OK. Click open button from here and select the front hub carrier left part. OK, and place the file in this assembly. It will keep as absolute origin. Choose the isometric view. Okay, now we will hide the visibility of the datum plane and sketches like this. Save the assembly. Now we will apply the fixed constraint over this part. Okay. Now rotate the assembly minus 90 degrees from here. Activate the add component command and place the part pillow ball bushing and pillow ball retainer in this assembly. Now choose move option in the positioning section and click OK. Now drag the part from here. Okay, alright. Now activate the move component command and select this part and drag the part like this. Okay, now we will rotate the component in this position. Okay, activate the constraint command. Now choose touch option. Okay, now we will select this face and select this face and apply the constraint. Okay, now we will fix the center axis constraint between this cylindrical face of the part and this face of the part. Okay, that's it. Now see. Rotate the assembly in this position. Now we will apply another center axis mate between these two cylindrical face of the components like this. Now we will activate the distance constraint from here. Okay, and select this face of the pillow ball retainer and select this face of the front hub carrier left part and fix the distance value minus 0.15 inches and click OK. Now see, my pillow ball retainer part has been fixed over this front hub carrier left part. Okay, now we will place another copy of these two components in this assembly. Drag the part like this. And apply the same constraints on these two components that we had done earlier. Select this face, okay, and apply the touch constraint between them. Now choose in for axis constraint from here. Okay, now we will select the center axis of the pillow ball retainer part and select the whole axis, select the bottom whole axis of the front hub carrier left part, okay, and apply the axis mate between them. Now see. Now we will apply the distance mate between the back face of the pillow ball retainer part, okay, and select the back face of the front hub carrier left part and fix the distance value 0.15 inches. Okay, alright. Now see. Okay, now we will hide the visibility of the assembly constraints by using show and hide command. Okay, now my model is looking very clear. Now we will insert the rear hub bearing part in this assembly. Okay. Rotate the assembly in this position. Okay, alright. Now rotate the bearing in this side. And apply the axis mate axis mate between the hole of bearing and hole of the front hub carrier left part. Okay, that's it. Okay, now we will drag the rear hub bearing in front side. Okay, and now we will apply the touch constraint between this slot face of the front hub carrier left part and back face of the bearing. Okay, that's it. Now my bearing has been fixed over the front hub carrier left part. It looks great. Now we will insert the front axle and front hub bearing part in this assembly. Okay, alright. Now rotate the component in this position. And drag the front axle in front side. Okay. Now we will activate the assembly constraints command from here. Choose infer axis mate option and select this face of the front hub carrier left part and select the cylindrical face of the front axle part and apply the axis mate between them. Okay, that's it. Now choose this face of the hub bearing and select this face of the front hub carrier left part and apply another axis mate between them. Okay, alright. Now we will apply the touch constraint between this face of the front hub carrier left part. Okay, rotate the assembly and select the back face of the bearing and apply the touch constraint between them. Now select the back face of the front axle part and select the top face of the bearing and apply another touch constraint between them. Okay, now see, my front hub bearing and front axle part has been properly fixed over this assembly. So now we will place another part on this assembly like 0.1875 ball stud part. Okay. Now drag the stud in this position. Now we will select this face of the stud part and select the top face of the front hub carrier left part. Okay, and apply the touch constraint between them. Now we will choose the center axis option, center axis mate option, and select the cylindrical face of the ball stud part and select this whole face of the front hub carrier left part and apply the axis mate between them. Okay, now see, my ball stud part has been fixed over this hole. Now we will create another new inch assembly file on here. Its name rear hex hub assembly. And now we will place the part hex drive in this assembly. Okay, that's it. Now choose isometric view from here. Now we will apply the fixed constraint over this part. Now activate the add components command from the graphics area and place the part hex axle pin in this assembly. Now we will choose the move option under the positioning area and click OK. Now drag the pin like this. OK. Now we will choose the touch align option and select this. And select the cylindrical face of the pin. OK. And select the whole of this hex drive part and apply the axis mate between them. Now choose isometric view. Now we will edit the pin part and open the visibility of datum coordinate system of this part. Okay, return back to the assembly. Activate the assembly constraints command. Now choose touch constraint. Now we will apply the touch constraint between the x-axis of the pin and x-axis of the hex drive. Okay, alright. Okay, now see my pin part is fixed over the whole of hex drive part. Okay, save the assembly. Now we will insert the hex retaining O-ring part in this assembly. Rotate the ring in a straight position. Fix the touch constraint between these two z-axes of the components. Now select the XY plane of O-ring and select the YZ plane of hex drive and apply the touch constraint between them. Okay. Hide the visibility of assembly constraints and datum planes. Okay, now see O-ring has been fixed over this assembly. Close the assembly. Back to the front hub carrier left one assembly. Okay, and place the rear hex hub assembly on here. Okay, that's it. Now we will apply axis constraint between this hole and the cylindrical face of the front axle like this. Now drag the rear hex hub assembly and fix another axis constraint between the hole of the front axle and pin. Okay, now this assembly has been completed here. Let's start the new assembly, which name is wheel assembly. Click OK. Alright. At first we will place the part wheel on here. Okay, apply the fixed constraint on over it. Now rotate the wheel in a straight position and insert the part tire 2 in this assembly. Rotate the tire in this position Okay. Now we will apply the infer center axis constraint between the cylindrical surface of these two components. Okay, alright. Now we will fix the touch constraint between the inner slot face of the tire and back face of the wheel. Okay, now rotate the wheel assembly in a straight position. Now my wheel assembly is looking perfect. We will edit the tire 2 part and open the visibility of datum plane of this part. Okay, return back to the assembly. Now we will apply the touch constraint between the YZ plane of tire 2 part and YZ plane of the wheel. Okay. So now this assembly has been completed here. Close the wheel assembly. Back to the front hub carrier left underscore 1 assembly. And place the wheel assembly on here. Okay, that's it. Rotate the assembly in this position. Now we will move the assembly in the rear side. Okay. And fix the infer center axis constraint between the inner cylindrical surface of the wheel and the outer cylindrical surface of the front axle pin. Okay, that's it. Now drag the wheel in back position. Now we will apply the angle constraint between the edge of hex drive and the internal edge of the wheel assembly. Fix the angle value 180 degrees and click OK. Save the assembly. Now we will apply the touch constraint between the inner face of the wheel and the back face of the hex drive part. Now we will place the ANSI B18.2.4.4M nut part in this assembly. And fix the nut over the wheel assembly in the following way. So now we will create another new assembly file on here. Its name is front hub carrier right. Okay. And place the part front hub carrier right in this assembly. So now we will follow the same process for making this assembly that we had done earlier over my front hub carrier left assembly. Okay, that's it. Now my assembly is about to complete, so we will place the wheel assembly. Okay, fix the wheel assembly over this assembly. Okay, alright. Okay, now my front hub carrier right assembly has been completed here, so we will close the assembly. Now choose add component command from here, okay, and place the front hub carrier left assembly in this suspension assembly. Now we will drag the front hub carrier left assembly in front side, okay, by using the move component command, okay. Rotate the assembly in this position. Now we will rotate the front hub carrier left part in this direction by dragging this arrow like this. Now we will drag the wheel assembly near side of the front upper R mount part. Okay. And activate the assembly constraints command from here. Under the orientation area, we will select the infer center axis option. Okay, and select the outer cylindrical face of the pillow ball part. Okay. Next, we will select the inner hole face of the front hub carrier left bar and apply the axis made between them. Okay, see. Now we will fix another infer center axis constraint between the lower pillow ball part and lower hole of the front hub carrier left assembly. Okay, that's it. Now we will drag the front hub carrier left assembly in this position to check the assembly constraint. Okay, now see, my front hub carrier left assembly has been properly placed over my suspension assembly. It is looking perfect. So let's insert the next subassembly on here. We will place the front hub carrier right assembly on over it. Okay, and we will rotate the assembly in this position by activating the move component command. Now we will activate the assembly constraints command. Select this internal face of the hole. Okay, and then next we will select the face of the pillow ball part and fix the axis constraint between them. Okay, see. In the same manner, we will apply another axis constraints between the opposite side of these two components like this. Okay, alright. Now we will drag the front hub carrier right assembly in this position to check the assembly constraint. Okay, now see, my two subassemblies are fixed here. Okay, it looks great. Save the assembly. Now we will choose an isometric view. Okay. We will place the ISO 4672-M3 bolt in this assembly. Okay. Now we will select the cylindrical face of the bolt and whole face of the front side plate left part and apply the axis constraint between them. Choose the touch constraint, okay, and select this slot face and select the head of the bolt and apply the touch constraint between them. Okay, alright. Now see the result. In the same manner, we will place the same bolt on here. And fix the bolt beside the first bolt. Okay, alright, we will insert the washer on here. Its two copies will keep in the assembly. Now we will drag the washer from the center origin point to separating it. Okay, select the whole of the washer and select the cylindrical face of the bolt and apply the axis constraint between them. Now we will apply another axis mate over the second washer like this. Select this face and back face of the washer and apply the touch constraint between them. Okay, that's it. Now we will place the two copies of this bolt in this assembly. We will drag the nut from the center origin point to separating it. Okay, now we will fix these two nuts over the bolts in the following way. Now we will place another board on here. Okay, now place the two copies of this part. Now drag the board in this direction. Okay. And fix the axis constraint between this board and lower hole of the shock absorber assembly. Now we will rotate the board by dragging this arrow. Okay. Now we will apply the infer center axis constraint between the cylindrical face of the board and the lower hole of the shock absorber assembly. Now we will select the board face, okay, and rotate the assembly in this position. And select the circular face of the front lower arm part and apply the axis constraint between them. Here you can see that the shock absorber assembly has come in front of the lower arm by using the axis constraint. Okay, that's it. And fix the second bolt over the opposite side hole of the shock absorber assembly. Okay, now we will place the two copies of the washer part in this assembly. Now we will apply the center axis constraint between the hole of washer and bolt. Okay. Now choose the touch constraint and select the front face of the washer and back head face of the bolt and fix the touch constraint between them. In the same way, we will fix another washer over the opposite side of the bolt like this. Now we will apply another touch constraint between this face and front face of the washer. Activate the assembly constraint command and select the edge of ball end part and now rotate the assembly and select this face of the washer and apply the touch constraint between them. Now we will apply the same constraint over the opposite side. Finally, my two shock absorber subassemblies are fully defined by fixing the bolt nut and washer. Okay, that's it. Now we will insert the 4 copies of the bolt in this assembly. Drag each bolt one by one by using the move component command, something like this. Okay, now rotate the bolt in a straight position. Okay, alright. Hide the visibility of the datum planes of these bolts by using the show and hide component command. Now we will fix the bolts over the 4 holes of the front upper arm mount part in the following way. Okay, now see my bolts are properly fixed on the front upper arm mount part. Okay, it looks great. And save the suspension assembly. Now we will also create an assembly arrangement in this assembly that we had done on my shock absorber assembly. Its name is right bump. So now we will activate the assembly arrangements command from here. Okay, and create the arrangement right bump. Click OK. Now we will go on the suspension assembly, then arrangements, okay, and choose the arrangement right bump, okay, and select the shock absorber assembly, right click and choose unpack option. Now see the two shock absorber assemblies are visible in the assembly navigator dialog box, okay. Choose the top shock absorber subassembly, right click and go to the arrangements and choose the closed arrangement. Okay, now we will go to the default arrangement position from here. Now we will test this newly created assembly arrangement on here, that how it works. Now choose the front view and activate the right bump arrangement from here. Okay, now see here my right side shock absorber assembly has been lifted in an upward direction from the assembly's floor. Okay, it is properly worked on here, it looks great. Now we will choose the default arrangement from here. Okay, now save the assembly. Finally, my suspension assembly has been completed here in Siemens NX. I hope you will enjoy this video. If you may like this video, please like and subscribe to our YouTube channel. Please share this video with your friends and colleagues. So now I will meet you in our next video. Okay friends, goodbye.